Okay, I hope I'm audible to all the students who are attending this lecture of Mathematical Methods for Economics, Part 1. Okay. In the last lecture of MME, we were discussing about limits and derivatives. We were discussing about the topic which we were looking at was limits and derivatives, which is formally chapter 4 of Sitsater and Hammond. Sitsater and Hammond is your main book, okay, for the entire economics honors course, and limits and derivatives is the topic which we were looking at. And in the last lecture, we had started with limits. In the last lecture, we had started with limits and we had done a few questions on limits. Uh, we had done the type 1 limit. So students who have joined for the first time today, please don't worry. After the lecture, I'll explain you how to access those lectures which you have missed. Okay, what we plan to do today. So type 1 was covered in the previous lecture. I am writing type 1 limits involving factorizing, expanding, limits involving factorizing, expanding, and rationalizing. So we had covered this in the previous lecture. So I can write covered in the previous lecture. Okay. Now what we are doing today, what I'm doing today is the limits involving infinity. Although I had covered this also in the previous lecture, but I start from this topic again. Limits involving infinity. So I request all students attending this lecture to quickly start writing in their registers. We are doing type 2 of limits, which are limits involving infinity. I had covered this in the previous lecture, but I intend to start from this again in this lecture. So all students will write along with me. Let us look at the rules of infinity. Okay, let us look at the rules of infinity. Before starting, just an announcement. Any student will unmute their mic only if they have a doubt regarding the topic. Okay, otherwise, all to keep their mics on mute as well as the videos on mute. Okay, so let's look at the rules of infinity. The first rule which we had done, infinity plus infinity is equal to infinity. The second rule is k times infinity will be equal to infinity if k is greater than 0 and minus infinity if k is less than 0, where k is a constant. So if you multiply the constant by infinity, you will get plus infinity if the constant is positive. You will get minus infinity if the constant is negative. The third rule which we had done in the previous lecture, infinity divided by k will be equal to plus infinity if k is positive, minus infinity if k is negative. We had done this rule also in the previous lecture. If you divide infinity by a constant, you get infinity if k is positive and minus infinity if k is negative. Okay, then we had done the fourth rule of infinity. Infinity to the power k is equal to infinity if k is positive, okay, and 0 if k is negative. So this was the fourth rule. You raise infinity to a positive power, it will be equal to infinity. You raise infinity to a negative power, it will be equal to 0. The fifth rule, infinity into infinity is equal to infinity. Okay, product of infinity is infinity. The sixth rule, e to the power infinity is equal to infinity. And the seventh rule, 0 upon infinity is equal to 0. Okay, I can also write along with this, guys, e to the power minus infinity will be 0. E to the power infinity is infinity, e to the power minus infinity is 0, 0 upon infinity is 0. So these were the 7 rules of infinity, which I had covered in the previous lecture. Okay, and then we had also discussed in the previous lecture the indeterminate form. So I am erasing the initial part. Okay, we look at the indeterminate forms. So indeterminate forms, basically these forms, we do not have the answer to these. So first one, infinity minus infinity, we do not know the value of infinity minus infinity. Okay, these are indeterminate. That means if you get a question where you have one of these forms, you cannot find the answer. Okay, so one form is infinity minus infinity, second form is 0 to the power 0. You cannot find the answer of 0 to the power 0. Third indeterminate form, 1 to the power infinity. You cannot find the answer to this. Fourth indeterminate form, infinity by infinity. We don't know the value of infinity by infinity. Fifth, we don't know the value of 0 by 0. Sixth indeterminate form, we don't know the value of 0 into infinity. So please don't think that 0 into infinity is 0. We don't know the value of this. It's indeterminate. And the seventh indeterminate form, infinity by 0. So guys, when I say indeterminate, that means you cannot find the value of that particular term. So we cannot find the value of infinity minus infinity, 0 to the power 0, 1 to the power infinity, infinity by infinity, 0 by 0, 0 into infinity, and infinity upon 0. Now, in case any student attending the lecture has a doubt, particularly regarding type 2, rules of infinity and indeterminate forms, only that student will unmute their mic and ask. If you have a doubt regarding the rules of infinity or indeterminate forms, you can unmute your mic and ask. Okay, so then we can move forward. So I am erasing all this. Now, in case any student has not written this, I will explain you how to get access to all this. But for the time being, erasing all this. And now our heading will now become limits involving polynomial functions. Limits involving polynomial functions, where we will be evaluating the limits up to infinity. So guys, suppose I have this limit as x tends to infinity. Suppose guys, this is my polynomial. All of us know that ax square plus bx plus c is a polynomial. It's a quadratic polynomial of degree 2. Now, how will I evaluate this limit? Okay, so let's understand this, how we evaluate the limit. Step 1, take the highest x term outside the bracket. So what's the highest x term? X square. X has a highest degree of 2. That means you take x square common. So its limit as x tends to infinity. I take x square common. Inside, what do I get? A plus b by x plus c by x square. This is the procedure you will follow every time. Whatever is the highest degree of x, you take that common. Okay, now if I put infinity in this, now I can just put infinity. So infinity square, I can put x as infinity, a plus b by infinity plus c by infinity square. Now all of us know from the rules of infinity that anything upon infinity is 0. We know that anything upon infinity is 0. So I can write infinity square into a plus b by infinity is 0 plus c by infinity square. Now guys, infinity square is equal to infinity only. If you look at my rule, if you recall, infinity to the power k is equal to infinity if k is positive. What is k here? 2. It's positive. So I can say infinity square is equal to infinity, and anything upon infinity is 0. So my answer comes out as a times infinity square. And guys, again, infinity square is equal to infinity. So what will my final answer be? Now all of us know this will be equal to infinity if a is positive, minus infinity if the value of a is negative. Look on to the rules. I just gave you the rules. K into infinity is infinity if k is positive, minus infinity if k is negative. So I hope all students have understood the procedure which we have used. So in every question where you have a polynomial, and they are asking you to evaluate the polynomial, the limit as x tends to infinity, this is the procedure you will be adopting. Take the highest degree of x common. In our example right now, it's x square. Inside we get this, then we put infinity. B by infinity is 0. Infinity square is infinity. C by infinity square is also 0. Infinity square into a plus 0 makes it a times infinity square. Infinity square is infinity. A into infinity will be infinity if a is positive, minus infinity if a is negative. So I hope so
Excuse
far.
me, sir.
Please ask your doubt.
Sir, do we have to write the infinity rules side by side or is it understood?
No, it's understood. It's completely understood. The rules for infinity were specifically given to you to understand. In the question, you can just apply the rules. Okay,
Sir,
so yeah, ask your doubt.
sir, can you please explain again how b upon infinity and c upon infinity square is 0?
So basically, you can write it, anything upon infinity is always equal to 0. Anything upon infinity, you can write it in your register, anything upon infinity is equal to 0. Basically, when infinity comes in the denominator, that the value of that expression is 0. It's a rule. Okay. So I hope I can move forward. Okay. This was a polynomial function. Now, guys, let us evaluate this function. So consider evaluating the limit. Now, guys, let's consider a general rational function. All of us know rational functions are the form p by q. We know the concept of rational functions. So suppose I need to evaluate this limit. You can see the limit I am writing on the screen. So I can stretch it to an xn. It is a polynomial of degree n, because the highest degree is n, upon b0 plus b1x plus b2x square plus bm xm. Now, guys, all of you can see the numerator is a polynomial of degree n. The denominator is a polynomial of degree m. Now, guys, what is the step we'll use? you will use exactly the same step which we had used in the previous question. How will I solve this? In the numerator, what is the highest degree of x? X to the power n. Take it common. Inside, what am I left with? Now it's a0. Outside, I've taken x to the power n common, so this will become x to the power n plus a1 upon x to the power n minus 1, because this and this will cancel and make it x. A2 upon x to the power n minus 2, and similarly I can stretch it, an upon x to the power n minus 1. 1 minute, we don't need to divide here, it will just be an. So you can see how I've taken xn common. So that is the rule which we had followed in the previous numerical as well. You take the highest degree of x common. So we have taken x to the power n common. Inside we are left with these terms, divided by, in the denominator, what's the highest degree? M. You take x to the power m common, b0 upon x to the power m plus b1 upon x to the power m minus 1 plus b2 upon x to the power m minus 2, and I can stretch it to bm. So I hope all students attending the lecture have understood this step. Okay.
Sorry, sir.
Yeah, is there a doubt?
This is not clear. Yes, sir. Why we took this x and we can take x square because the highest power is
No,
x square.
the highest power, you can see it is stretching up till xn. The denominator is stretching up till xm. So highest degree in the numerator is n. Highest degree in the denominator is m. And
Then why? Then
that is
sorry, sir.
yeah, that is the method we use. You must have joined late, so you must have not understood it, because I had clearly defined in the previous numerical which we had done that whenever you are evaluating a polynomial, whenever you are evaluating the limit of a polynomial and the limit involves infinity, you always start with the first step as take the highest power of x common. So I am exactly following what I had mentioned. Okay, so this is the procedure we use to evaluate the limit. I am explaining the procedure to you. In the numerator, x to the power n is the highest degree, so you take x to the power n common. In the denominator, m is the highest degree, so you take x to the power m common. Inside you are left with this. Okay, now I can further write it as limit as x tends to infinity. Now guys, x to the power n upon x to the power m. Using the concept of power functions, I can write it as x to the power n minus m. Numerator is this. I am writing it as it is. This is our numerator. Okay, and the denominator also I write as it is. b0 upon x to the power m plus b1 upon x to the power m minus 1 plus b2 upon x to the power m minus 2, and I can stretch it up till bm. Okay, so now guys, the time has come for us to put infinity, because ultimately we need to evaluate the limit as x tends to infinity. So if in the expression, if I put infinity, what will I get? So to solve that, I am erasing the initial part. Students know the question now, so I am erasing this up. So now if you guys put infinity in this, let us see what do we get. So I can write it as, if I continue with the solution on the top, limit as x tends to, okay, I am now putting infinity. So if I put infinity, what do I get? Infinity to the power n minus m into a0 upon infinity to the power n plus a1 upon infinity to the power n minus 1. And guys, I can stretch it up till an upon, in the denominator, it's going to be b0 upon infinity to the power m plus b1 upon infinity to the power m minus 1. And I can stretch it up till bm. Now, just now, a few minutes back, we learned anything upon infinity is 0. And infinity to the power anything will be equal to infinity if the power is positive. You can see that n minus 1, n minus 2, dot, 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 all of them are positive. m minus 1, all of them are all positive. That means I can write it like this: infinity to the power n minus m into a0 upon infinity to the power n is infinity. This will also be infinity, and I can stretch it up till an. What am I using? I am using the rule on the top. Infinity to the power k is infinity. Similarly, guys, in the denominator, infinity to the power m, infinity, infinity to the power m minus 1, infinity, and so on till bm. So I hope all students are clear till here. So now, if we further solve this up, so erasing this, I'm erasing all this now. If we further
Sir?
evaluate this up, yeah, ask your doubt, please. No
Sir,
annotations. Yeah.
is it like specified that n and m are positive numbers?
Yes, exactly. N and m are positive integers. In this question, n and m are positive integers.
So, sir, it will be written in the starting of the
Yeah,
question.
exactly, exactly. Yes.
Okay, sir.
Okay. Now, guys, all of us know anything upon infinity is 0. So this is 0, this is 0. Everything will be 0 except an. Similarly, this will be 0, this will be 0. Everything will be 0 except bm. So my answer comes out as infinity to the power n minus m into an by bm. Now, guys, everything depends on what? Everything depends on the sign of n minus m. Our final answer will depend on what is the sign of n minus m. So for that, we have the following cases. Guys, if you follow me carefully, you'll understand everything. You just have to be patient and understand what I'm speaking. Okay. So after putting in infinity, this is what we get. Now we have the following cases. Case 1. When n is greater than m, I can say that is degree of the polynomial in the numerator is greater than degree of the polynomial in the denominator. So guys, when my n minus m is positive, n more than m means n minus m is positive. Now, if n minus m, if the power is positive, answer is infinity. So I can write required limit for case 1. The required limit will be infinity into an upon bm, because n is greater than m. That means n minus m is positive. The power is positive means answer is infinity. Now this further will have two cases. This will be equal to infinity if an by bm is positive, and this will be equal to minus infinity if an by bm is negative. Because all of us know k times infinity is equal to infinity if k is positive, minus infinity if k is negative. So have all students understood case 1? Any doubt to any student in case 1? Feel free to unmute your mic and ask.
So constant upon infinity is also 0.
Yeah, exactly. Anything upon infinity is 0. Okay.
So,
Yeah.
so when we say so when we say that constant upon infinity is 0, then sign of constant doesn't matter.
No, it doesn't. No, it matters. It matters. If you must have written my rule, k upon infinity is equal to, yeah, okay. In that case, sign doesn't matter. In that case, sign doesn't matter. Very good. Yes. Anything upon infinity will be 0 irrespective of the sign of the constant.
So we can add this rule to previous page.
Yeah, you can add it to
Yeah.
the previous page. You can add this to the
So,
previous page. Yeah, ask your doubt, please.
but infinity upon constant will be infinity, and we will look after the signs also, right?
Exactly. Very good. Yes. So I hope students are clear with case 1. So I am erasing case 1 and I am doing case 2 now. Okay. So let's look at case 2. Let's look at case 2 now. So case 2 is as follows. When n is less than m. Now all of us know, I am not writing it in words, but you know it. N less than m means degree of the numerator is less than degree of the polynomial in the denominator. Now in this case, guys, what will the required limit be? If I say that n is less than m, it implies n minus m is negative. Okay, so infinity to any negative power becomes 1 upon infinity into an by bm. I hope students have understood this. For example, suppose my n is 1, m is 2. Suppose my n is 1 and m is 2. Infinity to the power 1 minus 2 will be infinity to the power minus 1, which will be 1 upon infinity. And 1 upon infinity into an minus bn will always be 0. Because anything upon infinity is 0. So I hope students have understood case 2. When the degree of the polynomial in the numerator is less than that of the denominator, required limit is 0. And then we can look at case 3. Case 3 is when n is equal to m. Case 3 is when degree of the polynomial in the numerator exactly equals degree of the polynomial in the denominator. Now guys, in this case, what will the required limit be? So required limit will be, now guys, look at it. What was our limit? If you remember, the required limit was limit as x tends to infinity, x to the power n minus m. We have not put infinity right now. Limit as x tends to infinity, x to the power n minus m, and inside we had an by bm. So basically everything else became 0. So now when n is equal to m, it's x to the power 0 into an by bm. Because if n is equal to m, it's 0. Anything to the power 0 is 1. So we have limit as x tends to infinity, a constant. And guys, limit as x tends to infinity, a constant is exactly equal to the constant itself. So my answer will be an by bm. That means if the degree of the numerator, polynomial in the numerator exactly equals the degree of the polynomial in the denominator, the required limit will be a constant. Because n is equal to m, it is x to the power 0. Anything to the power 0 is 1. 1 into an by bm is an by bm. Limit as x tends to infinity, constant is the constant itself. So I hope that the students attending the lecture have understood this case.
Excuse
Okay.
me, sir.
Yeah, ask your doubt.
I wanted to ask one thing in case 2.
Mm-hmm.
You have written there 1 upon infinity and in brackets an upon bm. So when we
Yes.
will multiply it, it will be an upon infinity and bm.
No,
So
you can
there
write
it,
it. You can write it like this. Basically, I'm answering your doubt. 1 upon infinity into an by bm. Answering your doubt, we can write it like this. An by bm divided by infinity, and anything upon infinity is
yes, sir. Now it's 0. Okay. Yes.
okay. I knew that this doubt will come, so I hope now this is understood. Okay, guys, now let's do some practice questions based on this type. Okay, so
Excuse me, sir.
yeah, ask your doubt.
What is infinity to the power 0?
Infinity to the power 0 is again indeterminate. We don't know its infinity. Yeah, again it's indeterminate. We don't know its value.
Okay, sir.
So infinity to the power 0 is not 1. Okay. Yeah. Again, good question being asked. Okay. So let's look at the practice questions based on this type. So these are practice questions based on limits involving polynomial functions. Okay, so let's look at these questions. Question 1. Let us evaluate this limit. Limit as x tends to infinity, 5x4 plus 4x cube minus 3x square plus 10 upon minus x plus 5. Okay, so let's solve this question. You can see numerator is the polynomial of degree 4, denominator is a polynomial of degree 1. So if I evaluate this, how will I evaluate it? Take the highest power common. What are we left with? 5 plus 4 by x minus 3 by x square plus 10 by x4. In the denominator, what's the highest power? X to the power 1. So take that common. Okay. So what do we get inside? We get minus 1 plus 5 by x. This is what we get. So this I can write limit as x tends to infinity. X4 by x is x cube into the remaining. I can write now, guys, we just need to put infinity. So infinity cube into 5 plus 4 by infinity minus 3 by infinity square plus 10 by infinity 4 upon minus 1 plus 5 by infinity. What will my answer come out? Infinity cube into 5 plus 4 by infinity 0 minus 3 by infinity square 0 10 by infinity 4 0 upon minus 1 plus 5 by infinity 0. So we get infinity cube into 5 by minus 1 minus 5. Infinity cube is infinity into minus 5, which is equal to minus infinity. My final answer. What have I used? We have just used the rules of infinity, which I have taught you today in the lecture. Now, if you are clear with those rules, you can solve all type of questions based on this type. So hoping students have understood this. For practice, let's solve another question. Let us evaluate limit as x tends to minus infinity, 2x plus 3 upon minus 4x plus 5. So guys, degree of the polynomial in the numerator 1, degree of the polynomial in the denominator 1. How will we solve this? Take x common, 2 plus 3 by x. Okay, and here in the denominator again take x common. X and x cancel out, put minus infinity. 2 plus 3 upon minus infinity upon minus 4 plus 5 upon minus infinity. This I can write as 2 minus 3 upon infinity upon minus 4 minus 5 by infinity. Anything upon infinity is 0. So my answer is 2 upon minus 4, which is minus half. This is my final answer. So you can see, since the degree of the polynomial in the numerator is same as that of the denominator, you are getting a constant. Okay, so now guys, some homework for you, and then I wind up this lecture, and then we have another lecture today. So homework is evaluate the following. Limit as x tends to infinity 5 upon 6x minus 3. Limit as x tends to minus infinity minus 2x plus 10 upon 4x square plus 6x plus 11. And the third question, as x tends to infinity, 2x cube plus 7x plus 10 upon x minus 5. 3 questions for homework in today's lecture. So I hope all students have enjoyed this lecture. I request all students attending this lecture to leave this meeting and join back again using the same link. Please leave this meeting and join back again for the next class using the same link. Okay.